Hello Year 7, welcome to this lesson. It's our first, I guess, enrichment lesson. So we're going to look at some of the more complicated work now from primes, composites, and factors. But before we begin, let's look at our solutions, or our solution to the puzzle from last lesson. So we've got a spreadsheet here, and in the spreadsheet, in this column here, or this cell here I should say, I type in the median of A1, B1 and C1. In this cell here, I type in the minimum of A1, B1 and C1. And up in this cell here, we type in A1 minus B1. And we're going to find the highest common factor. We're going to use these two numbers, 2322 and 654, because they were the two numbers that we used last time. So let's type them in, 2322 and 654. And what we're going to do is we're going to be filling down. So I'm going to highlight all these, and we're going to fill all the way down till we get to a 0. Looks like I've got one more to go. Yep, there we go. So what I'm doing is I'll get rid of the highlighting. I'm going to fill all the way down till I've got a 0 here. And what you can see is we've got 2322 and 654. We divide them. There's our remainder, 1688. We divide them again, and you may notice that it looks a little bit different to our Euclidean algorithm. That's because instead of actually doing a division, we're just taking off the numbers one at a time. So let's look at this one here, for example. We know that when I did the 2944 divided by 66 step, 66 actually fitted into 2944 4 times, and then we just did 66 times 4, 66 times 4 plus 30 equals to 294. But this spreadsheet, instead of saying 66 goes into it 4 times, we've got to do 1 time, 2 times, 3 times, and 4 times. So they're doing each step separately, which is why it takes a bit longer, but the logic is still the same, and we can see if we follow it all the way down here like this, and you can see here we're just taking off 294, we're taking off 66 one at a time till we get a number less than 66. So we're starting with 30 here, and we take a number off one at a time. We take 6 off, 1 6 at a time, until we get down to a number less than 6, instead of immediately saying, oh, well, 30 is just 6 times 5, remainder 0. But it is still the same logic, and we can see here we've gone down to 0, and these last two numbers, which are the same, tells me the highest common factor, and that's just 6, as we discovered last time. Okay, so onwards with the next thing. What we're going to do now is we're going to try and find all the factors for 360. And you might be wondering why I've written a square root of 360 there, and I'll show you why. The reason is when I'm looking for the numbers that are going to be factors of 360, what I'm going to do is I'm going to first work out just what the square root of 360 is, and there it is, 18 point something. And now I'm just going to work out the factors up to this square root, okay? And you're going to see why I'm going to do that in a sec. So let's write them out. 1, 2, 3, 4, 5, 6. Oh, feels like every number's a factor, but not 7. 8, 9, 10, 12, 15, and 18. And you're going, okay, well, why am I stopping at 18? I know that if I've got a square root of a number, and I'll just do another little example here. If I was to say have 36, right? And if I had 36, and I go, the square root of 36 is 6, and then I get the factors like this, 1, 2, 3, 4, and up to 6, and up to 6, there we go. All the numbers, I'll just move this screen across a little bit, all the numbers that are above the square root of 36, so that are above 6, are going to pair up with the numbers below it, okay? Because I know that 6 times 6, and my computer's just lagging here, so you'll just have to wait for it as it fills in. So we know that 6 times 6 is 36, so we know the numbers are going to pair off. 4 will have to pair up with something bigger than 6, 3 will have to pair up with something bigger than 6, 2 and 1 will also have to pair up with things bigger than 6. So hopefully you guys can see the numbers here. They're 9, they're 12, they're 18, and they're 36. So that's why we only need to go up to the square root, because every number below the square root will have a matching number above the square root, and then we can find the factors in pairs rather than having to think of all of the big numbers. Alright, I'm just going to rub this off because it seems to be creating some issues with the program. Alright, so let's hope it's good now. Alright, so let's now go back and do the rest of the factor pairs. So 18, well, 18 times 20, 15 times 24, 12 times 30, 10 times 36, 9 times 40, 8 times 45, 6 times 60, 5 times 72, 72 is an easy one to miss, 4 times 90, 3 times 120, 2 times 180, and 1 times 360. So there you go, a little tip how to find all the factors there. We just count up to the square root, which is 18.97, and then we fill them all up, and then we count the pairs back down. Let's count how many of them there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 times 2, 360 has 24 factors. So what I want to show you now is a fast way to work out how many factors a number has without actually having to list them all. So we're going to use 360 again, just so we can test it really is 24. So the question is, we're going to find out how many factors of 360 there are. Now don't worry about what's on this right hand side for the time being. Let's just look at what I'm going to do here. I'm going to go 360, and I'm doing a prime decomposition. You know how to do this now. 36 and 10, 6, 6, 5 and 2, 3, 2, 3, 2, 5, 2. So here's our prime decomposition. 2 to the power of 3 times 3 squared times 5. And I'm just going to start with the 2's, okay? I'm thinking of all the possibilities that I could have for my 2's and my factors. I could have a 2 to the power of 0, and I'm even going to write all the little options here. I could have a 2 to the power of 0 in one of my factors. I could have a 2 to the power of 1. I could have a 2 to the power of 2, or I could have a 2 to the power of 3. So I'm just going to do all my 2 to the powers of 0. Now, let's imagine I had 2 to the 0, 3 to the 0, 5 to the 0. 1 times 1 times 1. Oh, that's the smallest factor, it's 1. Now let's get my next 2 to the 0 one. I could have 2 to the 0, 3 to the 0, and 5 to the 1. Oh, well that's 5. 1 times 1 times 5. So that's all my 2 to the 0, 3 to the 0 factors. I could combine them with a 5 to a 0 or a 5 to the 1. Now I get my 2 to the 0 and 3 by 1, 3 to the 1. Well, that's going to be 3 times 5 to the 0 is one option, or 5 to the 1 is the other option. I can't have 5 to the 2 because I've only got one 5 here, so I could have a 3 and a 5. So I'm going to do all my factor combinations like that. So I'm going to start with my 2 to the 0, and that's just one option for the 2, and then from this I'm going to list out all the options for my 3's. 3 to the 0, 3 to the 1, and 3 to the 2. So for this one, 2 to the 0, 3 to the 1, 5 to the 1. It's 15. And if I have a look, how many options do I have? Well, for every 2 to the power of 0, I've got 1, 2, 3 ways I could have the 3's. But for every single one of these ways I could have the 3's, I've got 1, 2 ways I could have the 5. So let's now count them up. Well, I've got 4 choices for my 2. 2 to the 0, 2 to the 1, 2 to the 2, 2 squared, or 2 cubed. But for each of these 4 choices, I've got 3 ways I could have my 3. So 3 to the 0, 3 to the 1, 3 to the 2. Pair it with this one, pair it with this one, pair it with this one, pair it with this one. So even before I think about all these 5's here, I've got 1, 2, 3, 4 options for the 2's. 1, 2, 3 for 1, 2. 1, 2, 3 for another 2. 1, 2, 3 for my third 2. 1, 2, 3 for my fourth 2. 12 options because I've got 4 by 3 for each one. But for each of these 12 options, I have 2. Here and here, here and here, here and here, and so on and so on. And you can see I've actually worked out all the factors like this. Notice that when I do it this way, I do get all the factors, but I don't actually get them going in ascending order. But that actually doesn't matter too much because I just wanted to know how many there were. So I go like this. The total number of factors. So we'll just say the total, and I think I've got it right here. If I write too far to the left, my software slows down. So the number of factors equals to 4 times 3 times 2, and you know that's 24. And the reason for that is you can see I've got 4 options for the 2 because I could have a 0, 3 options for the 3, 0, 1 and 2, and 2 options for the 5, 0 and 1. So what I do is I basically add 1 to each of these powers and I times them together. And you can see the reason why over this side. Okay, on to our algebra review. Now, last lesson you saw how to expand these brackets, so hopefully you'll be able to do it this time fairly easily. Do pause the video and actually have a go at these before you watch, just so you can check if you're getting it right. So I hope you've paused and had a go now. So what we do is we times the 3 by the x and the 3 by the y, and we get 3x minus 3y. For my second one, I've got 2x cubed up the top, so that's going to be 8x cubed over 2x squared. I hope you guys are happy that that's 2 cubed and x cubed. I cube both the things inside. Now I can cancel down this fraction, and I know that 8 over 2 is 4. And I know that x cubed divided by x is x to the 3 minus 2, which is x to the 1, which I just write as x. Okay, my third question, a number, and we call the number x, is doubled, and then we add 5, okay? So what I do is I start with my number x. If I double x, I do 2x, because 2x is double x, and then I add 5 to it, nice and easy. So you might find that one fairly easy, but we'll be doing more of these in the future where it's going to get a little bit trickier. Oh, and I forgot to tell you, this previous work we did here, working out all these options, is called combinatorics. So it's a type of maths, and you do a bit of more of it this year. It's called combinatorics. So if you want to look that up, read ahead in your Euler books, or even watch some YouTube videos about it, there you go, that's what to look for. Okay, the homework. So for the homework, you're to do your Euler Chapter 2, and you're going to do questions 1 to 6, and that means 1, 2, 3, 4, 5, and 6. It doesn't just mean 1 and 6. Then you're going to do 11, 12, 13, 15, 16, and 17b. To find your Euler book, we have uploaded them for you. If you go onto your Classery under Maths, let me get my pointer here, your Classery under Maths, you go to MCYA Enrichment Euler. If you click on that, MCYA Enrichment Euler, you then open it up and there's something called Euler Student Notes full PDF. If you have a look through there, you should be able to find the questions. Okay guys, thank you very much and see you next lesson.